And that gave me problems this morning trying to open up everything, put it together. So I was opening up the file 3.1 to insert 3.1, and I forgot which one I was doing. And so yeah, I was having issues this morning.
James had a remark. Oh
Okay.
my gosh, I didn't realize it was the third month. I thought it was the second one.
Hannah's really smart.
I get
3.1, quadratic functions and models. Number 1, polynomial functions. I'm about to say something that's very important. The domain of any polynomial function is all real numbers. That's important. The domain of any polynomial function is all real numbers. What's that mean?
That a polynomial function is always a real number.
The domain is a real number. What's that mean?
X.
X can be any real number. X can be anything. Okay? Very important. A quadratic function is a polynomial function. We're going to talk more about graphing techniques. We've done compressions and stretching and translating, right? Reflecting. We've all done all that. We're still doing graphing techniques. Last semester, we did completing the square, and we're going to do some more completing the squares. We're going to look at the vertex formula of a quadratic. If a quadratic is in vertex form, I can look at the equation and tell you exactly where the vertex is, just by looking at the equation. Okay? And then we'll look at quadratic models, meaning word problems using quadratic formulas to solve. Okay? A polynomial function takes the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1x plus a naught. What that means is a polynomial function, you're going to write it down with the highest exponent on the x first. Isn't that what we do all the time? Highest exponent, and then we count down, right? Okay. Here are 5 different polynomial functions. F of x equals 2. Where's the x?
In the parentheses.
A in
It's x to the 0, right? And x to the 0 is 1, so it's not necessary, right? Okay. So there is no real variable in present. Therefore, it's just the number 2, and the number 2 is a constant. So if you see f of x equals a number, that's just a constant function. Leading coefficient is whatever that number is, and obviously the exponent on the variable is 0. So it's degree 0. A linear polynomial has an x in it, x to the first power. This particular one has degree 1 because that's the highest exponent is 1. Thank you. I'm not here. This was not here. This was not. Okay. So 5x to the first power, the exponent on that x is a 1, which makes it a first degree polynomial. The coefficient on that x term is 5. Therefore, the leading coefficient is 5. Y'all remember talking about leading coefficients? Okay. The leading coefficient is the coefficient of the term with the highest exponent on the variable. Okay. So looking at the quadratic, it's actually colored for us. The highest power is 2. That makes it a second degree polynomial. The coefficient on the 4x squared is 4, which means 4 is the leading coefficient. 4x squared would be the leading term. The next one, 2x cubed minus 1/2 x plus 5. The highest variable is the 3. That makes it a cubic. That makes it a third degree polynomial. 2 is the leading coefficient. And the last one, the highest exponent is 4. That makes it a quartic. And I will tell you, most of the time, I'm not going to call a 4th degree polynomial a quartic. I'm going to call it a 4th degree polynomial. Okay? I'm not going to call an 8th degree polynomial an octic. I'm going to call it an 8th degree polynomial. It's septic. And that just sounds nasty. Okay? Okay, any questions on these terms?
Your remote's right there.
Thank you. Here is the general form of a quadratic. A quadratic in general form is ax squared plus bx plus c. A tells you a lot of information. If A is positive, it opens up. If A is negative, it opens down. If A is greater than 1, it's going to stretch it. Or less than -1, same difference. If A is between 0 and 1, or 0 and -1, it's going to compress it. Nothing new there. Notice the domain at the bottom. The domain goes from negative infinity to infinity. Does that make sense? Should it go from negative infinity to infinity? Yes, it's a polynomial function. The domain of all polynomial functions is all real numbers. The graph of a quadratic function results in a parabola. Parabolas are symmetric with respect to a line. This line is called the axis of symmetry, or axis. I will never say the axis of the parabola. I'm always going to say the axis of symmetry. There's only one point where a parabola touches that axis, and that is the vertex. Okay? The vertex can be at the top, which makes it a maximum, or it can be at the bottom, which makes it a minimum. There you go. Next slide. F of x equals a parentheses x minus h squared plus k. That is vertex form. If I have a parabola in vertex form, just by looking at it, A tells me the direction of opening. We've already talked about that before. If A is positive, it opens up. If A is negative, it opens down. If the absolute value of A is greater than 1, it stretches. If the absolute value of A is between 0 and 1, it compresses. H is the horizontal shift. Remember, it is inside a grouping symbol. So it's backwards from what you might think. K is a vertical shift. The vertex of this parabola is HK. Questions? Anything on that? No? Okay. We're going to graph this function by plotting points. We're also going to talk about the domain and the range. What's it doing? Okay. Why is it all real numbers?
Because it includes every x value.
Because it's what kind of a function? Because it's a polynomial function. The domain is all real numbers. Don't know about the range yet. We'll get there in a minute. Okay. Because the domain is all real numbers, that means x can be anything. And we are going to graph this by simply plotting points. What strategy would you use in plotting points on this thing?
Plug it into my calculator and then copy the points.
Without a calculator.
Putting random numbers for x. That's what I do.
Random numbers for x? Okay, would anybody plug in 3.582?
No.
No, okay,
Probably
I
not.
want normal number.
That's very normal.
Whole number.
Whole numbers.
Is that
Okay. Whole numbers or integers probably.
Yeah.
So would you maybe make a T-table
Yeah,
and start plugging numbers in? Okay, so what numbers would you like to plug in?
2.
Okay, so plugging in a 2, I get 2 squared, which is 4, minus 4 times 2 is 8, minus 2. 4 minus 8 minus 2,
-6.
negative 6. The point 2, negative 6 is on my parabola. What else?
6.
-2.
Positive
Okay.
6. Just kidding.
Y'all are being difficult compared to other classes. All right, so negative 2 squared is 4. Negative 4 times negative 2 would be plus 8 minus 2. 4 plus 8 minus 2. Okay, so negative 2, 10. Okay.
1.
Huh?
1.
1? Okay, y'all are really random. So throwing a 1 in there, we get 1 minus 4 minus 2. 1 minus 4 minus 2 is?
-5.
1 negative 5.
4.
We're now going to 4. All right. 4 squared is 16. Minus 4 times 4 would be minus 16 minus 2.
-2.
Or negative 2. I'm not seeing any symmetry yet, are you?
So I think it's because of our numbers.
0.
No, no,
Okay,
no.
plugging in 0 is super simple. Oh, I should have written that down here. Negative 2. Okay. Plug in 0. 0 is easy. You just cover those up and you got. So 0.
go.
Wait, why is
That would mean that.
Okay, can you see symmetry yet?
Yes.
3.
Or -1.
I think
You should
negative
plug in
2
3.
is our.
So plug in 3
axis.
Yes.
and you get?
You get negative
Negative 5.
5.
Okay, so we're seeing symmetry now,
Oh, you're smart.
right? Which means this point up here is 4 away.
No.
1, 2,
Yes.
3, 4. So 1, 2, 3, 4 right there.
1 more over.
Now do your lines. I want to see how many.
Okay, you want to see what?
Do this is the lines.
What lines?
The lines.
Oh, the curve?
Yes.
The parabola, the line. It's not a line, it's a curve. Okay, and of course, this is the perfect parabola.
I think the
Obviously.
smart board.
Okay.
gives you all.
So, yeah, it's a smart board, not very smart, it messed me up. Okay.
On the board.
What's the range?
-6. Wait.
Oh wait, I think it is. Actually, I don't know. So. Oh.
-6 and greater.
Okay, so does it actually start at -6?
Yes.
For sure.
No,
Is -6 included?
we don't
Yes.
know.
Yeah, it is. We got that point right there. So -6 is included. And how high does it go?
Infinity.
Infinity and beyond.
There you go. I've graphed it by plotting points. I've stated the domain. I've stated the range. Good?
Yes.
Any questions on that?
No.
Part B, g of x equals -1/2 x squared. We're going to graph that. We're going to compare it to the graphs of y equals x squared and y equals 1/2 x squared. So if we were going to graph y equals x squared, that's just the parent parabola, right? 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Axis of symmetry is the y-axis. reflect those points. And draw your parabola. What does y equal 1/2 x squared look like? What's that 1/2 do?
Compresses it.
It's a vertical compression, right? If you take that gummy bear, have a gummy bear in your hands, smush it, it's going to spread out, right? Because that gummy bear's got to go somewhere. And hopefully not through your fingers. Okay, so the x values will stay the same, but each of the corresponding y values you can get in half. So half of 0 is 0, so it's still there. Half of 1 is a half. Half of 4 is 2. Half of 9 is 4.5. And the next point would have been 16. And half of 16 is 8. And it hasn't shifted anywhere, so it's still symmetric about the y-axis. So I can reflect those points. And draw this curve. So this is the graph of y equals 1/2 of x squared. Is it wider?
Yes.
Okay. Part B. I want to graph negative 1/2 x squared. What's that going to look like?
Reflection across the x-axis.
Reflect which one?
The red one.
1/2.
Yeah, I'm just going to reflect the red one. Tell me, right? I get cross-eyed standing up here at the board sometimes. Okay, so I've graphed the function. What is the domain of g of x?
I'll remember.
Okay, so negative infinity to infinity. And what is the range of my purple function? Where does it start? What's the smallest possible x value? Smallest possible y value?
Negatives infinity.
So it's going to go from negative infinity to
0.
0
Bracket.
bracket. Because clearly at the origin, that is the point 0, 0, so I do have a y value of 0. Okay. Too easy? Too easy.
No. I think we'd set this differently.
All right, so look at this function we just graphed. Look at the equation of g of x. You got that equation in your head?
No.
I'm about to move to the next slide. How did it change?
-4 plus
Has an F now.
Other than the letter. How else did it change?
Wait, it goes to the left.
It's translated
Right.
to the right. Yeah.
Oh, yeah.
And then it shifts up 3, right? Right? Someone?
Yeah.
Anyone? Bueller? Anyone?
I think I'm pretty close.
I'm just doing a quick sketch, it's ugly though, of the graph that we just did. Okay. So that was the graph of part B. It was a slightly wider parabola opening down. Where are we now? What did I say I did?
Moved right 4 times. 30 minutes.
Okay.
great.
Which means if I take every one of those points that I plotted for negative 1/2 x squared, move every one of those points to the right 4 and up 3, we're good to go, right? Okay. This point, right 4, up 3, is right there. Right 4, up 3. Right 4, up 3. And so on. Reflect it across its axis of symmetry. Do those graphs appear to be the same, just shifted? And because I'm such a perfect artist, they're exactly the same, but shifted, right? Work with me here, thank you.
I think they're the same, but I want to go try to say perfect.
No, they're exactly the same. They both suck. Yes, ma'am.
Very Lord.
Okay. In general, the graph of a quadratic function, f of x equals a, x minus h squared plus k, is a parabola with vertex hk, and axis of symmetry, x equals h. Parabola opens up if a is positive, down if a is negative. If I give you a quadratic in general form, to make it into vertex form, we must complete the square. So we're now going to complete the square.
No. Wait, what?
We're going to graph x squared minus 6x plus 7. After we graph it, we're going to find the largest open interval over which the function is increasing. We're also going to find the largest open interval over which the function is decreasing. But the first thing we're going to do is write this in vertex form. So we have to complete the square. Remember, when you're completing the square on the terms that include x's. So I'm going to complete the square on the part x squared minus 6x. So to start this, I will write f of x equals. I'm going to put this perfect square that I'm about to create in parentheses. So open parentheses, x squared minus 6x, and let me pause there. I am a perfect artist. If I tell you this is something, then it is. Okay, I'm going to draw a perfect square.
Imagine if it was actually perfect.
Imagine.
That's a rectangle.
Oh, wait, that's not a square.
Okay, that's a perfect square. It has 4 sides, and all sides are exactly the same.
Doesn't even
No.
have 4 sides.
Oh, so what do I have to do to that to make it a perfect square? Do what?
Add a corner.
I need to add a corner?
Chop a bunch of.
Okay, so I need to take
You need to complete the square.
that, right? So if I added this to what I started with, would that give me a square?
No, yes.
Again, my art skills are on point,
You were almost there.
okay? Mr. Martinez would be jealous. Okay, does that make sense?
Nope.
If I have something that's not a perfect square, the only way to make it a perfect square is to add something to it. That's what it is. To make a perfect square, you have to add something. Now, I could add something that's positive, I could also add something that was negative. But regardless, to make a perfect square, I must add something to it. Okay? So, to complete this square, I'm going to have to add something to it. Here's my plus 7. And because I'm only working on one side, I don't have an equation where I'm doing something to both sides. I'm only working on one side. If I add something to this side, how do I balance it? Take it back away. So because I'm adding something, I must subtract something. What's the something? Y'all remember?
Oh wait, it was half of.
Or 7.
No.
Okay. Oh yeah, there was half of something,
It
yeah.
was half of X. Half of
Okay.
6.
Half
Half of something.
What's B?
Hey, C?
Negative 6.
It's
B is negative 6. What's half of B?
-3. That's 9.
And what is half of B squared?
9.
9. To make this a perfect square, I have to add 9. Okay? Now, in this problem, A is 1. My leading coefficient is 1, so things are nice and easy. Okay? This trinomial is multiplied by 1. And 1 times 9 is
9.
9. So because I added 9, to keep it balanced, I must subtract 9.
Wait, so if A wasn't 1, we would multiply?
Next problem. Yeah. But we did. We multiplied 1 times 9.
Did we do this last semester?
We did. Okay. So because I was very specific in choosing that 9, I made that a perfect square. This trinomial factors into x something squared. What's the something?
It's like -3 or
The
something.
something is the half b.
Oh my gosh, I'm so smart. I said that. Everybody knows that I said that.
You said -3.
Yep.
And then I can do some math outside my parentheses, right?
No, yes.
7 minus 9, -2. I can tell you, I can finish this problem except the graph with that part right there. Okay.
Where did -3 come from?
Half of b.
Where did the -6x and 9 go?
Okay, what's x times x?
X squared?
Okay, outside times outside, what's x times
Oh,
-3,
okay. Okay, that makes sense.
right? So that's -3x, -3x, you -6x, and there's a 9. I factored it. Where's the vertex? I have a vertex at 3, -2. Why? Because h is 3 and k is -2.
Wouldn't it be a -3?
The formula says x minus h. So h is 3.
Okay.
And the formula says plus k. How do you get a -2 out of a plus k? K must be -2 then. Graphing this. I know for sure that the point 3, -2, 1, 2, 3, -1, -2. I know for sure that that point right there is on the graph. Y'all agree? That's the point 3, -2. Does this parabola open up or down?
Up.
It opens up. Okay. So I've got this parabola. I'm going to graph it in a minute. Let's talk about when this thing is increasing or decreasing. In the United States, we read from left to right. Reading from left to right. Go all the way back to -infinity. Where's the graph at?
Infinity.
Way up there, right? And what's it doing until it gets to this point?
Decreasing.
It's going down, it's decreasing, okay? This function is decreasing from negative infinity until it gets to the x value.
3.
Till it gets to 3. And what happens when it hits 3?
It starts to increase.
It goes up
It starts increasing from 3 until
and then infinity.
infinity. Only thing we have not done yet is graph it. Okay? Where's the y-intercept?
7.
7. 1, 2, 3, 4, 5, 6, 7. Right up there. There's no stretching on this thing, is there? Any stretching?
No.
No. So it's going to be closed down here, and it's just going to open up like this. Okay. I pretty much did a sketch. You could plot more points and get a better graph, but I didn't want to spend time doing that. You could type it into your calculator and go to the table and find more points, right? Is that what y'all would do?
Mm-hmm.
Yeah. 100%.
Type it in your calculator, go to the table. Sure. Unless you just want to practice plugging numbers in and doing the math. You can do that too if you want to. Any questions on this one?
No.
Thank you. You all right over there?
Yeah, I kept falling asleep, and I
Okay.
don't want to stand in the camera, so I.
Okay. You can come stand over here if you wanted.
That's okay.
Okay. We're going to graph negative 3x squared minus 2x plus 1. We're going to identify the intercepts of the graph. We're going to find the vertex by completing the square and writing this in vertex form. I'm going to complete the square on this piece here. However, to complete the square, the coefficient on my x has to be a 1. That's not a 1. I have to make this negative 3 a 1. And I can't just randomly multiply it by stuff because it's not an equation, and I've got to do the same thing to both sides. So what I'm going to do is I'm going to factor out a negative 3. By factoring out that negative 3, what I'm actually going to end up doing is dividing both of these terms by negative 3.
Wait, can't you find
Because if I divide both these terms by negative 3 and then turn around and multiply by negative 3, won't I get what I started with?
Yes.
Okay, so negative 3 divided by negative 3,
Wait, why can't you?
One.
1.
1. So there's my x squared.
Why can't we factor out x?
I need to have the x squared term and an x. If you factor out an x, you don't have a quadratic anymore.
Okay.
Okay? So I'm factoring out a 3, which means I need to divide these both by negative 3, because later on they'll be multiplied by negative 3 to undo that dividing. What is negative 2 divided by negative 3? Positive 2/3.
Wait, what?
Negative divided by negative is a positive. Okay, now just to check it real quick. Negative 3 times x squared is negative 3x squared. And negative 3 times 2/3 x
Negative 2.
is negative 2x. So I got what I wanted. Okay, so to complete the square, I'm going to have to add something here. There's my plus 1, bring it on down. And because I'm adding something, I have to subtract something to keep it balanced. Now let's find the something. What is the b that I'm working with?
2/3.
B is 2/3. What is half of b? What is half of 2/3?
Or
1/3.
1/3.
1/3, yeah.
And what is half of b squared? What is 1/3 squared?
2/3?
2/3.
I don't know.
Okay, I'm gonna write it out
Oh,
here.
wait, 2/6.
I've heard the correct answer.
1/9.
1/6?
Okay, it's 1/9.
Oh.
Oh.
Oh, I was doing 3 times 2.
Remember, 1/3 squared means 1/3 times 1/3. To multiply fractions, you multiply straight across. 1 times 1 is 1, 3 times 3 is 9.
There you guys, step up the game.
Okay? So, to complete the square, what must I add?
1/9.
1/9.
1/9. Did I add 1/9?
Oh, wait, no.
Yes.
No, I did not.
This thing.
I added 1/9 inside a set of parentheses. These parentheses are multiplied by this -3.
Oh, you added.
So this -3, I need to pick it up. There's -3. I'm going to multiply it by this 1/9.
-1/3.
Okay?
-3.
And that would be -3/9, right? And -3/9 reduces to -1/3. And that's what you asked about a while ago. Right? Questions on what just happened there?
No.
Why didn't you use the regular 1/3, which is half of B like you did in the first?
I'm not there yet.
What?
Half of B went in the next step.
Oh.
Okay. That B, the half of B squared went in the first line. And that was multiplied by 1. But on this problem we're doing now, I'm not on that step yet. Okay. I carefully selected numbers to make this work. I made this a perfect square. So we have f of x equals -3 times x
Plus 1/3.
plus 1/3. Why is it a plus 1/3?
Because the B.
Because b is a positive 1/3. But that's squared, right?
Dude.
And then I have a plus 1 minus a -1/3.
Plus 4/3.
Okay? Yeah.
Better. Would it also be correct to just write +1/1/3?
We don't do that. Yeah, we quit, as soon as we got to high school, we quit using mixed numbers.
I'm a little late.
Yeah, if you're a little late, join the program. Unless you're talking about like, I'm not gonna say that I ate 4/3 of a cupcake. I would say I ate 1 1/3 cupcakes. That kind of makes sense. See the difference? Okay. We're not gonna take 4/3 of a bus somewhere. We're gonna take 2
2.
buses. Okay, yeah. I don't wanna be on that 1/3 bus. That's gonna suck.
I think that'd be good.
Okay, where's the vertex?
Oh, wait, hold on. I don't actually know. It's -1/3.
It's 1/3 and 4, no, negative.
And then 4/3.
It's negative.
Okay, the vertex is located at -1/3, 4/3. Okay. I'm not gonna spend time graphing this. We'll look at it on the calculator. It does say though to find the intercepts. And so let's start with the y-intercept. Where is the y-intercept?
1.
The phone knows. To find the y-intercept,
Oh, it's 1.
x is 0. And when x is 0, y is 1. To find the x-intercepts, and let's see, the vertex is at I'll just sketch it real quick. The vertex is at negative 1/3, positive 4/3. It's up here somewhere. And which way is this parabola open?
Down.
Is it going to touch the x-axis if it opens down? Twice? Okay, we'll continue tomorrow. I was thinking 15, my bad.
And then I like touched it and it just went, I like, so when you open it, there's like a pipe, like, I squeezed it